Our protocol provides a technique to customize nanoparticle distribution fabricated on a substrate with changing the dewetting dynamics without changing the material thickness. Our technique is simple, yet still provides a range of particle sizes. Other techniques out there require extensive lithographic steps to provide the particle control. Our control of particle distribution provides a technique for nanoparticle fabrication that benefits research focused on solar energy conversion, creating photonic devices, and increasing density of data storage. Pay close attention to the deposition thicknesses at each step. Our technique is extremely sensitive to layer thicknesses. Seeing the experiment performed provides a level of detail that can be conveyed in print. Seeing the samples moving throughout the process is essential.
First, clean a 100 nanometer silicon dioxide on silicon substrate using an acetone rinse, followed by an isopropyl alcohol rinse. Dry the substrate using a stream of nitrogen gas. Load the substrate into a thermal evaporator system and evacuate the chamber to reach the desired pressure for the deposition of the metal film. Ensure that the chamber is evacuated to a pressure on the order of 10 to the -6 torr for the removal of air and water vapor in the chamber. Using the thermal evaporator system, deposit the gold film at the desired thickness, which is 5 nanometers in this experiment. At the second deposition stages, the argon pressure is 1 to 5 millitorr, and the range is given as different pressures are chosen to calibrate for the deposition rate.
Our technique is extremely sensitive to film thicknesses as shown in our result.